Greetings, everyone. This is my fourth video, and it's going to be a departure from usual. I'm going to drop my Goat Oracle persona. For anyone who cares, I'm only going to use that when I rant. If I begin to rant on IT topics, and that becomes a thing, then I may go back to it for fun. But for these, I'll keep it more professional, just in case. I don't want to annoy anyone who's trying to get something, get some professional value out of this. There is a public GitHub repo associated with this. There isn't a ton in it that you might need, just some shortcuts and some of the Crossplane CRDs themselves. This demo is to demonstrate Crossplane for the most part. I'm using a KinD local Kubernetes cluster. You could use anything. The scripts assume KinD, but K3s or there's a number of options. Minikube. If you want to go old school, Minishift. Should work on any of them, I believe. OpenShift may have some weird issue with this. I'm not sure. I've never installed Crossplane on OpenShift specifically. I'm also going to be using Localstack installed onto the KinD cluster as well. I'm going to expose it as a service simply to, this will work, of course, with any live AWS account, but again, runaway costs are an issue for some. I don't like to chance them myself. I've had some bad experiences there if one isn't careful. So Localstack is a great product. Runs a container or two or three, depending on where you put it, either locally in a container run, via container runtime of your choice, or via Kubernetes and whatever container runtime you've set up for that. I will be installing it Kubernetes natively here just to make accessing the pods easier without having to introduce extra Docker networking or other such things. But again, of course, an actual AWS account will work. This is I can go into more if I'm looking for feedback as always. So if folks want me to delve more into cloud-specific cloud-specific tooling and demos around that, I will. I didn't use EKS here again specifically just because the cost on even an EKS control plane can be a little high. Not if you just run it for a quick second, to be honest. But nothing here should be expensive if you decide to run any of it live. I will go over the contents of the GitHub repo for just a moment, and then I will attempt to demonstrate its usage on the cluster to create a quote-unquote EC2 instance. Again, Localstack is just going to mock the response for us, which I'll port forward the service and use the AWS CLI to just confirm that it's been created. We'll go over Crossplane a bit. This assumes, again, familiarity with Kubernetes and AWS to a certain degree. I can do more Kubernetes-specific tutorials in the future as well. That would be no problem. So what we're dealing with as far as Crossplane goes, the startup script here, I'll go over everything real quick. The shell function script is just a bunch of environmental variables and an error reporting shell function. Me just being clever. I don't know why I spent so much time on this when I was doing it. But there you go. There's probably a smarter way to catch return codes, but this is also why you don't want to use bash to write create general tooling. So it'll source that. It creates a KinD cluster. It adds Helm repos to install Localstack and Crossplane. These are publicly. You may not be able to, depending on how sandbox you are, you may have issues here, but these are just public repos from home. That should be no problem from any low security environment. There are better ways to do all of this, including more Helm local mechanics. You could use things like customize, something like Argo CD or Flux or some other pipelining tool. Could also automate this a little better than what I'm doing here. The problem that you're going to run into is that a number of these CRDs that Crossplane uses rely on each other, and they're not instant. It takes a moment for Kubernetes to quiesce any configuration change, of course, and this is no different. So I've added some sleep commands, just have it wait for a minute on each of these so that the dependent objects don't have to worry about. And again, this is just cheap, easy, stupid way to do this. There's many better ways to go about this, but I'm trying to focus on Crossplane more than the other options at this point. I'll give my opinion on Crossplane in the end, just briefly. Spoilers. I do think it's a useful tool, but boy, oh boy, just like a service mesh like Istio, or maybe even tools like ROCD. That's probably not that bad. But maybe something like Opa or Kyverno. These tools have a certain heft to using them that folks, I think, tend to forget has a operational overhead. They are fairly complex tool sets themselves. So, but I'll give my overall opinion of Crossplane in the end. And this should create all the objects. And by the end of it, we should have a working mock, at least. KinD config doesn't do anything. I just included it for my own convenience and stuck it in here in case somebody wanted to use it. It doesn't do anything except spawn one worker and a control plane node. In Crossplane, we have a number of different options, a number of different CRDs that configure various elements. For example, if Crossplane creates an element, creates some sort of infrastructure component out via a cloud API, let's say it creates a AWS EC2 instance or an S3 bucket or creates a new VPC or anything. Crossplane calls these managed resources. They're the ones that are managed on whatever platform is outside of the Kubernetes cluster that Crossplane is currently running on. Although it can deploy to its own cluster too. So that's not a great explanation for it, but anything that is the result of Crossplane compositions, let's say, or composite resources or something along those lines, you have, it would manage resources, the physical infrastructure involved, whether that's actually virtual or not. Confusingly enough, you can already see Crossplane has some confusing demarcations for things. You have, so to create these managed resources, you can do it directly, but it is not recommended that one do so in most cases. Crossplane's main function is to create open API based API. We'll call them APIs. We're just going to call them APIs. Kind of these sub APIs that allow you to turn Kubernetes into a control plane for just about anything. Someone famously used Domino's pizza ordering API for their online, for taking web orders, and created a Crossplane XRD. We'll go over those in a moment. The composite resource definitions, and created a composition around, and the only resource it was creating was a pizza order, but that's what they did with it. So you can use Kubernetes to order pizza or make tea. Whether you want, so we'll cover that at the end as whether or not you're going to want to do that, again, because there's a lot of overhead, but it's still a pretty cool process. And for those who are engaging in platform engineering, this tool makes sense for you, especially because otherwise you will have to have something else that will, absorb whatever configuration layer you're handing your developers, be that a YAML file, a JSON file, or anything else for that matter. The recommended way to kind of handle this, and that's what I tried to work off of here, is you have a provider, which is one or more software packages that basically have an internal, kind of like a Terraform. They're sort of going for Terraform provider, I think. It basically it's the internal logic for interacting with a specific set of APIs most of the time, such as on AWS or Azure, or maybe there's a Kubernetes provider, I think, that uses the Kubernetes APIs. There are a number of custom ones. You can write your own, of course. These providers are, we're going to be mocking AWS today. Haha, AWS, nobody likes you. No, I'm kidding. We will be mocking a service, though, from AWS, so we're using the AWS provider here. The provider config simply passes the credentials over to the provider, which, again, since we're mocking everything, these are all mocked credentials, credits. So this right here is base 64 encoded nothing. It is just a mock. Localstack does not care about authentication. They have a pro product that you can do a little more with that. I think I haven't really used it. If Localstack tutorials become popular, if people start asking me to do more on Localstack, I'll take it. But I may have to get pro at that point to really dig into the tool. It's very useful, very cool, and sometimes a lot faster. It doesn't get you throttled by AWS APIs for messing around too much. Although if that's happening to you while you're just testing, you might be testing a little harder than you should. This creates a secret for that. In the Kubernetes cluster, in the KinD cluster, we're going to install Crossplane 2. And then the provider config uses that secret as a source for it. And this could be other types of files. This could be an environmental variable. There's a few options there. Putting a secret into Kubernetes is the most common way to do this, it seems. I nibbed that off of a Localstack example. Then the endpoint, because Localstack, I could just have installed it in the same namespace as Crossplane, but since it's going in the default namespace, we're using the long form. It's not quite an FQDN, but the long form host name for the URL for this with the port that it presents. It pretty much takes in any API request for any API that it supports and then routes it. So you go to 4566. So you don't have to keep changing the port every time you want to access. It does offer other ports you could access in a pinch. And that'll tell the provider, the AWS provider, how to talk to Localstack in this case, or how to talk to AWS itself, and so on. These providers are accessed via either directly creating a managed resource, which is not what we're going to do today. It is an option, or through creating what Crossplane calls a composition. A composition has the composition itself, and it also has a function, one or more functions that it uses to manipulate these incoming requests. This part makes sense, but it's a little confusing this adds a lot of overhead to what you're trying to do, because it's very flexible, but you have to keep configuring everything. So you have to tell it what kind of composition to set up, what kind of templating to set up, basically, and then what functions to do it with. Very powerful, though. Very, very kind of open. This composition is basically a template, and it explains how, when I create something, when I create these composite resource definitions, we'll say, that's what uses these compositions. It's like a template spec, like a pod spec or something along those lines. It tells you how to create the managed resources in question when somebody passes you a custom. And we'll go into the claims. I didn't create any composite resources directly, but a claim is basically a namespaced version of that. So I'll go over that in a moment. So this is a very basic composition for a fake build server. The mode is pipe. You're going to see this a lot. There is a resource mode that's deprecated, so we're going to use the newer pipeline mode. Just for anybody who asks, the reason the KinD says X build servers to distinguish it as a custom type created in Crossplane. Usually there's a friendlier name for that once you create a claim or a composite resource. Here we're using that function, the patch and transform function. I'm using it in a default config. It is a very basic way to. I'll show this in a sec. It's a very basic way. You'll see here there's a patches option, and it's taking a spec that we pass in, and I'll show you that on the claim. That's sort of the custom API. It's a spec that only means something to Crossplane and tells it how to create whatever resources you want. No different than creating any Kubernetes native resource. That's kind of the nice part once this is done. Claims are not perfect, but you can easily absorb a YAML variable file or something like that, even a CSV if you want your devs to hate you. And here we'll see that the input, we're telling it specifically that it's going to get a resource type input. There are other inputs. I'm an intermediate Crossplane user, not an advanced Crossplane user at this point. So I'm not sure what the other options are there. for this particular function. There's also a number of functions I haven't used. This is just sort of the basic one. Again, I will do more Crossplane tutorials if this is something folks desire. The type of resource is the managed resource type is going to be called an instance. That's the AWS provider that we installed creates a number of CRDs around the resources it controls. There's buckets and there's IAM, there's policy for IAM and things like that. This is an instance for an EC2 instance. Shows you which which provider it's using. It gives it an API version. You can see the capitalized. I'm calling it an instance. I'm with a lower I here. It's probably not a good way to do this. It's probably best practice not to make it so close to the provided kind. But the for provider section of this is part of the spec. If you go to I won't show it here, but if you go to the Crossplane, if you go to Upwork, don't go to Upwork. What is it? Upbound? Upwork. Jeez. If you go to Upbound, nothing against Upwork. I didn't mean to bring them into this. If you go to Upbound site, you can find definitions for a lot of these providers, a lot of the configs. It's a little confusing to navigate. Documentation around Crossplane is not wonderful, I've found, but. So this for provider section is required for the managed resource, the resource that we're going to create, say the instance. It wants to know at least the image ID. These were the required ones. It wants to know which image ID. This is, I think, a made-up AMI. It doesn't matter. And which region you'd be in, which is typical for AWS to make sure that you're going for the right region. And then below it, you provide this provider config that we created here earlier. You tell it which one to use for this specific resource, and you have to kind of go. There are ways to do this a little more. I think there are slicker ways to do this, but you kind of have to go in and keep telling it which provider config to use over and over and over again in one fashion or another. There's a lot of work on the back end here, but you can, of course, template a lot of this out. I know this is a templating system, too many layers of templating, but you can template the creation of this out too, obviously, using Jinja, using Go templating, or using some maybe even a doc engine might be able to handle this. So however you want to expand text of this nature. But in any case, the config was called. Here, I'll show it. I called it example. So you go off the name of the object in Kubernetes. So we're saying we want to create an instance of any type. Well, an instance with this particular configuration. I think there are ways to overload it. But whenever we create an instance in this manner, we want to pass it this image ID in this region. And we could patch those so they can be overridden. These are sort of defaults at this point. Think of these like defaults. You can still break this out into numerous sub APIs, if you will, or sub instance configurations. This patches section is what this is doing, is allowed because of that function. I don't want to close that. Because of this patch and transform function. From composite field path, I'll show you what that is when we go to the XRD. It will take we're going to give folks creating these claims or composite resource objects. We're going to give them the option to specify just an instance. Just to make this simple, we're going to specify just an instance type. That's it, and that will translate into patching this for provider. That's what it's saying. Under the spec for this resource here, it will patch the for provider key, which is also itself a map. And then further, it will patch the instance type in. Now, this instance type spelled this way, again, you don't have to put a dash, so it's a little confusing. That's why you don't want to name things quite the way I'm doing it here. But the instance type is, again, based on the AWS provider for the instance managed resource. Instant type is just another default field that we can patch in to change it. I think the default is one of the old standard M class instance types. I think I overrode it to M5 large here or something along those lines. I think it's normally like an M4 small, or it's something older perhaps. I don't recall. And that's all that this is going to be doing for us. It's going to patch that in each time it creates. And remember, this is a template, so it's going to create an instance under the hood. And I'll show that instance once we have this all set up. It'll create an instance, and then it'll patch this over the definition before it fully commits it to Kubernetes for storage and etcd and so on. This composition allows us to create an XRD, a composite resource definition. These are the objects that use these compositions, which again are templates. Composition is a template. These are the objects that use those templates to create an API that we're going to access. So that instance, that this is an open API, as you can see here, it's an open API schema. I don't think there is anything other than V3 these days, but I don't know. It used to be called Swagger. It's open API now. I think most people would know that. Served means that it's active. Referenceable means it's the latest one, I think it is. If it's served as false, it doesn't work. And if referenceable is false, it means it's not the current version. There's probably a better explanation for that. Again, intermediate user. But that's the, if I remember correctly, that's the basics on these. You'd have served could be true on a number of them. Referenceable would be true on one. The other ones would be versions that were available but not being referenced by Crossplane. That's probably a better way to explain that. This quite simply connects the idea. This is a little confusing. This connects this example.org API group, which we've created custom inside of Crossplane. So Crossplane now has its own API group inside for an X build server. Plural is just how you refer to many. Just it's always in, I know it's always in lowercase. Just another confusing little anecdote. The X is to show that this is being created via a composite resource definition and is not a built-in type or from something that has extended Kubernetes in one of the more standard fashions. All this serves to do, and I'll go back to the composition here. All this serves to do is to present the API specs so that you create a number of these instances in different ways. Here we're just asking for an instance type. You could have one of these that asked for different AMI IDs, asked for different subnets it might be in, or asked for different storage options. You can go crazy with it. And each one of these XRDs would be considered different. This would be different than if you included instance type. I believe, if I remember this correctly, if you included instance type and then you added another feature, that would have to be a different XRD, and it could behave in two different fashions. One if you only include instance type, and one if you don't. But again, I may be misunderstanding that, so please feel free to correct me on that one. I'm not 100% sure on that. So what we've got here is for each composition under the spec, you have a composite type reference, and it basically tells you which of these XRDs that this composition can be applied to. I think this is bass-ackwards. In my opinion, I think you should probably reference the composition via the XRD, but I'm not sure there's more. I think it's a one-to-one relationship, and maybe this is how they enforce that. But as you can see, we create this X build server XRD here, and then we get to use it here on this composition. So that means that this composition can be used to create these particular resources here, which again will be these instances, which I will show. It's just an internal representation of an EC2 instance. You then consume them with either a composite resource, just not a definition, just a composite resource object, or a claim. And a claim is the same thing as a composite resource object. It simply is namespaced. You can actually stick it in a namespace. Composite resources are cluster-wide, cannot be namespaced. So just bear that in mind when deciding which of these claims are the usual way you are going to be doing this. Ops teams and the such might create composite resources manually on their own for different reasons, but not the usual way you're going to do this for your dev team. The reason that you can use it, I will point out here that if we go down to this XRD, you need to have claim names built in order to be able to use a claim and give it a kind and a plural kind. Otherwise, it will not allow, it'll be limited to only composite resources and not claims. This is, again, in case you want to disallow the developers access to certain types of objects and object creation, but you want to use those yourself. As you can see here, this claim is creating a build server, which is our custom class here. We're going to call it test build server, and it's going to just set the one field that we are allowed to set, instance type, to M5 large. That's it. It should create, and I will verify this in a moment. Watches everything goes horribly wrong. It's worked several times now, but watches everything goes horribly wrong because I'm recording live. All right, looks like there's no clusters. I'm going to kick this off. This will take a moment. I apologize. There is artificial built-in delay here while I wait for objects to occur. So apologies for that. Feel free to. The one thing I do currently lack is video editing skills. Not something I've picked up yet. So these are very raw video, just stream of conscience, conscious stream of consciousness. I don't know about conscience, and so it's just kind of live and raw. So my apologies for that. As I get better at video editing, I will try to do more interesting things in my videos. But we all have to start somewhere. Once this is up and Localstack is showing that it's available, I will port forward the Localstack service. It has a Kubernetes service because I'm installing it into Kubernetes. By port forwarding the service, it will allow me to send requests to the. There was only one pod, so yes, you can port forward the pod as well. But this will just grab me. This will forward the information from a node port service, which is what Localstack will install, to my root namespace, root network namespace. This is really the only thing in the way. I could also use a command like nsenter to get into it, and also, I have other ways to do it. This is a convenient way since Kubernetes is already in the path. Once again, I do apologize for the delays here. This might be a good time to espouse Crossplane for what it is, rather than just wait until the very end. Overall, I'm going to say it's as you can see, it's a complex tool to get your hands on. This is a very basic configuration. It took me a few days to get this working right, and I don't have much to show for those few days. So if you don't have at least one or two preferably, good Crossplane SMEs or subject matter experts on your team, this is one of those, like a service mesh like Istio or something along those lines. This is one of those big hefts that will add a lot of operational overhead. It adds, obviously, there's a lot of good here, but if you don't have the team for it, if you're stretched thin or running a big tool stack, this itself could be a bit of a problem in that regard. On the other hand, if you find yourself in a platform engineering, more, the kind of newer use of the term, I suppose, if you find yourself working on an internal developer platform, if you find yourself working as a platform engineer, which I have done for the last few years, this tool is sort of purpose built for what you're doing. You can see that you can heavily abstract everything with a well-known system. However, again, bear in mind that you will need even more finagling on top of it if you just want to present your developers, your customers, with a PaaS type experience, platform as a service type experience, where they're handing in a YAML variable file, a JSON variable file, an INI, a TOML file. Like I said, CSVs if you want them all to hate, but some sort of serializable data format that you can just turn into variables usually is what ends up happening. And then you could template out these cross-plane CRDs. If there's any interest in a tutorial around that, I wouldn't mind going over some potential possibilities there with, say, Jinja. Maybe Go templating. My Golang is weak, but I could work on it. Something with Python, Jinja is a Python library, that might be easier. Or there are some tools that do it. We could do it in JSON and use JQ. Any of those, I could do some tutorials around that if there's interest. But yeah, just there's a big overhead here. So I think Crossplane is always, like any newer. It's not that new anymore. Any newer tool, it's worth POCing, but you'll quickly get a grip for how complex it is to keep this going. I've certainly created IDPs or worked on IDPs, I should say. It's not like I single-handedly created them. Both, a little bit with Crossplane and a bit without. And again, I'm going to suggest keeping Crossplane out of your tool set if you don't have at least one person on the team ready to deep dive and become a real subject matter expert. You're going to have a bad time. Otherwise, very useful tool though. Very useful tool. And once you got it set up, it can do a lot of cool things. So we should be done here shortly. Sorry again for the delay. All right, this should be just finishing up. And this again is why uh, just blanket wait statements, noops in a script is not the greatest way to wait for all this to become available. Helm has its built-in wait options, which I'm trying to use here, which helped. All right, well, here's the moment of truth. We will see if everything is okay here. So first we will. So what I'm going to first do is I'm going to show in the. I think that's the namespace. We're going to get the pods here. We can see that there's the Crossplane pod, which does most of the heavy lifting as far as translating the various the internal CRDs into something usable in the external Kubernetes cluster. We have the RBAC manager, which the sole job of this thing, I'm not an expert with this thing, but basically the sole job of this thing is to pass our credentials, however they are gathered, depending on how you set up, pass the credentials over to providers. Like provider AWS would be technically getting credentials from the RBAC manager. You'll notice it starts up a pod for each provider because this is what's going to be talking to, say, Localstack. And then you have the patch and transform function, which is providing that templating service we were talking about when you use that patch option. There's a number of these, again, that you can use to enable all sorts of functionality, depending on what you're looking for. It seems like the patch and transform is probably the most common one you'll see, but there were a number of other options. I would be happy to deep dive into them if that's anything anybody's interested in. Now, the first thing, we'll kind of go over everything individually, I suppose. If we get the providers, we should be able to get a list of, you can see that the Crossplane provider, AWS provider is available. It shows you which package is implementing it, whether it's healthy, and so on. We can get this Lambda functions, yeah. They're called something else. The function pods here are listed as some other object. I'll skip those. I obviously we could go dig into that. I'm not sure it's super important at the moment. I'm gonna be lazy and skip it. But there is a functions. There's some other name for them, I believe. If we get the composition, can I spell here? And you can see our X build server. Well, it's called just build server composition. It's the name of the composition. You can see it's attached to the XRD X build server. You can see what fake API group we gave it. The usual. We can get, should just be Zerds. To be able to get XRDs, we can see that it's established and offered. There's those referable and served options, I think, and whether or not it's currently functional. And I don't think there's a claims option. I think it would just be the resources, but yeah. Didn't think there was anything claimed. There is a composite. I don't think it's going to show anything, but there is a composite resources option, I believe. I didn't spell it right. There's some other name for this. And then now the managed resources, we're going to look at a managed resource called an instance. That is the other one I wanted to show. Sorry, this is just me tooling around here at the curiously. Uh, and that is one of the many managed resources that is delivered by the provider AWS provider. It's those the number of managed resources that you can use are based on which providers you have installed for the most part. I think you can install customs, but you're supposed to write your own providers is the way I believe you're supposed to handle custom resources like that. So we have something called an instance. Now it shows ready as false because I don't think if I pointed at Localstack, now this may be wrong, but I think if you point at Localstack, it'll never show ready because I don't think Localstack will issue the signal it's looking for, whereas the AWS EC2 API will give back a instance as ready. I'm not sure if that's the case. Synced means that it was able to create it and that its last update worked. Just syncing its impression of the instance with the so-called real configuration of the instance gives me an instance ID for it. Doesn't know the state because again, but if we go to this side here and I get services, you can see we have the Localstack service. Localstack is running in the cluster, and that is what Crossplane is accessing. If I port forward the service on port 4566, I can use the AWS CLI here. I'm going to pass it. This doesn't matter. For Localstack, this doesn't really matter. Maybe the Pro Edition might have some support for checking region and that sort of thing. I don't know. But shouldn't matter here. We are going to override the endpoint URL to this. So you'll notice it is forwarding to, it uses localhost to create I think it's SSH under the hood, actually. I may not be remembering that correctly. I believe it's SSH under the hood. So we're going to do a localhost URL at TCP port 4566, since that's, again, I'll just one more time, we have it being forwarded here from that network namespace that the pod is running in through the service, which is, this exposes a port, a node port service exposes a port on every, as you see here, 4566 is exposed on the host as 31566. And that port is what's actually going to accept the outside traffic. But I'm going to port forward from the inside. The API server is basically going to forward it's going to forward whatever I'm typing to the pod instead of going through the like NetFilter stack on my host. Although that is where it's going to end up because this is all local. That is where it's going to end up. Just So if I use a describe instances command here to just accessing the EC2 API to look for VM instances and as you can see here, it mocks all the usuals. It gives me a reservation ID. It shows the instance here. Everything else is pretty much faked. Hypervisor is just, they used to use Zen. I don't know if they still do. A lot of default info. And if we look at the instance type, there it is, at the bottom, we can see that it did set it to M5 large. And it does use our image ID that we set. And here's the instance ID that we saw earlier. So there you go. Now if I, and this will go away if I bring everything down. So, but what I can do is if I, and I think it may get recreated, but if I delete this instance here, that didn't, there we go. It may recreate it. I don't know. I don't think it does. And if I go back and flip out the flip screens there. So now if I run the command again, You know what? Localstack's not a good choice for this. I should have done this live. Okay. Normally, if the instance goes away at some point, though it does show terminated here. Oh, I know, it caught it. I was going to say there might be a delay using Localstack for this, but no, it caught it right away. Actually, it shows it as terminated. So as soon as the instance was deleted, it terminated this instance here. That's how the provider responded to it. What I was trying to show. Sorry, I thought I was going too fast for Localstack, but it is high quality product here. I'm just going to say once again, not to be a shill for OpenStack for Localstack. All right, well that is my I'm going to bring everything down here. That's what that is. That is my demo. It is raw again, raw and uncut. And I apologize for my lack of editing skills, but you know we all got to start somewhere. And if I start doing more of these, and any videos I may post up in the future. Still thinking of maybe a gaming video or two. But whatever I do, I will. You know, definitely taking requests. Any feedback would be wonderful. I will certainly dive into any topic I feel that I can be useful on. I may move my rant topics to more interesting things as well. If folks would like me to rant on the state of uh, cloud computing, rant on the state of machine learning. Not my specialty, but I could, you know. All right, folks. Well, you all have a good morning, afternoon, or night, and I hope to see you in the next one.